So now let's look into the third technique in data encoding, that is OneHot. After the OneHot encoding, we'll be looking into the dummy encoding. But before we enter into the dummy encoding, let's wrap this up. See, the dog animal, the category dog has been coded with 10000, cat 01000, sheep then 00100, and horse 00001, and finally lion with 00010. So that's how this each category in that row has been replaced with the respective binary code. Now it's time to jump into the dummy encoding. So dummy encoding scheme is similar to one hot encoding. This categorical data encoding method transforms the categorical variable into a set of binary variables, also known as a dummy variable or dummy variables. In the case of one hot encoding, in the case of one hot encoding, for n categories in a variable, it uses n binary variables. The dummy encoding is a small improvement over one hot encoding, that the dummy encoding uses n minus 1 features to represent n labels or categories. So to understand this better, let's see the following illustration or animation. So here we are coding the same data using one hot encoding. Like if you see that example in our next slide, so here if we had coded the same data using one hot encoded, we would have had three dummy variables. But here we are doing with the dummy encoding, we had only two dummy variables. Let's see. So first category of color is red, then green, then we have blue. Okay, so out of that, if you use a dummy encoding, you will get only, you have three categories, that's n is equals to 3. But for dummy encoding, you will be taking the n minus 1 dummy variables or n minus 1 dummy features. So that's why 3 minus 1, that's a 2 dummy features. So you got the d1 dummy 1, d2 dummy 2. So the red, if if the variable, the value of that color variable is red, then 1 and other one 0. If it is green, it would be red, would be the d1 would be 0 and d2 would be 1. If it is blue, neither d1 nor d2, you will have a 0 0. This kind of encoding is called a dummy encoding. I hope you got it. So by and large, the rules will be used similar to the no one hot encoding only. The same methods and no the same thing we can use it here also. Okay, but the main difference between the one hot encoding and dummy encoding is there we use you create n dummy. If you have n categories of your variable, then n features, n dummy features will be created. If you have n dummy n categories in your variable, then n minus 1 features will be created when it comes to the dummy encoding. So now let's see the difference between one hot encoding versus a dummy encoding. So let's put it simple. So same, we have a variable, a categorical variable or nominal variable. So it consists of three categories, and here is that red, green, blue. That means our n value is equal to 3. Okay, now if I do the one hot encoding, then my number of dummy features would be n only. So that's why I will have three dummy features, that is n1, n2, n3. So that's I have said here d1, d2, d3. So if the value is red and the dummy 1 will have 1 and d2 d3 will be zeros. If the value is green, then d2 will have 1 and others will be 0, and if value is blue, the d1 d2 would be zeros and d3 would be 1. This is what we call it as a one hot encoding. But when it comes to dummy encoding, the same applies here also. You have, you know, three categories, that's n is equals to 3. But when it comes to dummy encoding, the number of dummy features is equal to n minus 1. So then you will have only two dummy features, that's d1 and d2. Then how they were encoded? If the value is red, then dummy 1 will take 1 and d2 will be 0. If the value is green, then dummy 1 would be 0 and d2 would be 1. If the value is blue, neither dummy feature is 1. So both cases you will have a 0 0. So that's the main difference between one hot encoding and dummy encoding. So one hot encoder, what are the drawbacks of one hot and dummy encoding? One hot encoder and dummy encoder are two powerful and effective encoding schemes. Let me put here a dummy encoding. So the difference is Kaplan is equals to number of categories, then n minus 1 would be the number of dummy features. That's it, simple. Now, so drawbacks of one hot and dummy encoding. Uh, so a large number of levels are persist in data. If large number of levels are present in data, if there are multiple categories in a feature variable, in such a case we need a similar number of dummy variables to encode the data. For example, any column with 30 different categories will require 30 new variables for coding. Of course, these are dummy. 30 new dummy variables for coding. This is one drawback. Then if you have multiple categorical features in the data set, similar situation, like if you have multiple categorical variable with huge number of categories, then again the situation, we will end to have several binary features, each representing the categorical feature and their multiple categories. So that means, example, if you have a data set having more than 10 categorical variable with 10 categories each, then you will end up having 10 into 10 equal to 100 dummy variables. So this is the biggest drawback of this one hot encoding and dummy encoding method. In both the above cases, these two encoding schemes introduce sparsity in the data set, that several columns having zeros and few of them having ones. In other words, it creates a multiple dummy features in the data set without adding much information. So also they might lead to a dummy variable trap. We call this as dummy variable trap. So it's a phenomena where features are highly correlated. That means using other variables, we can easily predict the value of a variable. So it's a phenomena where features are highly correlated, but in actual case they are not. So due to massive increase in the data set, coding slows down. That's one more uh, drawback. Fourth one, due to the massive increase in the data set, coding coding slows down the learning model, along with deteriorating the performance of overall performance, that ultimately makes the model computationally expensive. So further, while using tree based models, these encodings are not an optimum choice. So that's a dummy encoding for us.